Okay, so today I will talk about properties of plane polar unit vectors, plane polar unit vectors, that is r cap and theta cap. So, so first of all, first property is here I will talk about relationship between dr d theta and theta cap. So for this, let us consider uh, r cap, and as we have discussed in the earlier lectures that r cap is the cos theta I cap plus sine theta j cap. So when I am taking the derivative of r cap with respect to theta, as we know that I cap and j cap, these are the unit vectors. This is along x-axis, this is along y-axis, means these two unit vectors are not changing while we are changing the theta. So that means this I cap and j cap are the constant. So I have to take only the derivative of this cos theta. So it can be written as minus sine theta I cap plus cos of theta j cap, means I have taken the derivative of this and this, right? So this is it. But if I recall theta cap, so what is theta cap? Theta is cap can be written as minus sine theta I cap and it's cos theta j cap. So that means this is basically theta cap. So that means I can write down dr cap over d theta, it is equal to theta cap. So this is the one relationship which we have to remember, and another is basically it is the relationship between this is d theta over d theta cap over d theta and r cap. So for this, let us recall theta cap, and theta cap is basically this one which I have written here. So it is minus sine theta I cap and it is the cos of theta j cap. Now if I take its derivative with respect to theta, again I cap and j cap are the constant directions. One is along the constant unit directions along x and the y respectively. So it is written as, it is it is minus the derivative sine theta is cos theta, minus will remain as it is. So cos theta I cap plus, sorry, and the derivative of cos theta is minus sine theta, so it can be written as minus sine theta j cap. So if I take it outside minus, so it is cos of theta I cap plus sine of theta j cap, right? So this is nothing but this is r cap, so it is minus r cap. So another relationship between this r cap and theta cap is this one. So it is basically, it is r cap with the minus sign with it. Then I will talk about another property or the relationship. Rather than calling it as a property, let me call it as a property. Sorry, it is third one is it is third one. So this property is that the plane polar coordinates r, means there are, simply I can say that r and the theta, these are the orthogonal So unit vectors are said to be orthogonal. Let me recall the definition of orthogonal. So that means unit vectors, or simply vectors, or simply vectors are said to be orthogonal if their dot product vanishes. If their dot product vanishes. So for this, let us consider dot product of r and theta cap. So their dot product can be written like this. So it is r cap dot theta cap. It is the value of r cap is cos theta I cap plus sin theta j cap, and the minus sign, it is minus sin theta I cap, and it is cos of theta j cap. So as I know that this, if I have given two vectors a dot p, then it written as ax bx, sorry, ax bx, ay by, and az bz. So these are basically, this is x component of a vector, this is y component of a vector, this is z component of a vector. Similarly, bx, by, and bz are the x, y, and z components of the b vectors. So that means this is multiplied by with it, and this will multiplied by with it, and I and j are not required here according to this formula. So it can be written as minus, yeah, it is minus sine theta cos theta, and here it is plus sine theta, and it is cos theta. So both are equal and opposite. So this is equal to 0. Thus r cap theta cap is equal to 0, and this shows that r cap and theta cap are orthogonal, right? This is a very important conclusion we are drawing here. So that means polar coordinates are the Cartesian coordinates, orthogonal coordinate systems. So thus we have, let me summarize these results, and after that I will stop. So that means what I have derived or concluded from this, that if I take the derivative of r cap with respect to theta, then it is equal to theta cap, and if I take derivative of theta cap with respect to theta, then its result will be minus r cap. And another is that r cap dot theta cap is always equal to 0. These are the three important conclusions which I am drawing from this particular lecture. So that's all for this lecture.